Hey everybody, what's going on? This is Big Mike. I wanted to upload a video because I know I haven't done it in a while, and I wanted to talk about a little bit what I've done for my embedded systems class. I know my last video I talked about receiving I bought a FPGA design board, but for my class I actually had to use a 32-bit microcontroller board, and it was actually a really fun class. It's kind of like Arduino but on steroids. And we had the ability to do a final project between three different embedded systems. So I thought it would be fun if I showed you guys what I did, because I had a great time doing it. I actually thought it was a lot of fun, and it gave me a lot of ideas for projects in the future. So what I did was I made a alarm clock. So the board that I used was a Nucleo board. That's what they call it. It's based on the STM32, so 32-bit microcontroller ARM variety. So it's an alarm clock that uses, so my peripherals were a 7-segment display. I have like one of those IR remotes, like a TV remote, and on the other side it had an IR receiver and an active speaker. So the difference between an active and a passive speaker is that the active speaker is you just turn it on and off and it makes the same tone, but a passive speaker you use PWM signals, and from there you can make whatever you want. So if you've had an Arduino class, think of the Pizio speaker. That's a passive speaker. You can actually control the frequency and the of the tone. With an active speaker you can't, and the only reason I chose active speakers is because I'm lazy. So I was going to use a real-time clock for the timekeeping portion of the project, but just because of the design requirements from the professor, I had to use either a hardware timer or middleware, and I decided to use the middleware. And essentially what this does is it puts a pretty basic operating system on your ARM processor, so the timer is kept using software timers instead of hardware timers. So like a hardware timer will use an oscillator or some sort of clock, but this is done purely in software, so I believe it uses a little bit more resources, but that ended up being a little bit more hassle than I thought it was worth. I only did it because it was a requirement, so in the future I think I would have just used a hardware timer. So you have the ability to program a certain alarm time, and when the chosen time occurs, the sound will be played on the speaker, and it's in 24-hour military time. So a little bit of basic descriptions. So the display is a 7-segment display, and the Nucleo board will light patterns to appear as numbers. So actually the way that a 7-segment display works is there's two varieties. So it's either a common cathode or a common anode. So think about it in a 7-segment. Let me pull up a picture actually. Let's look up like a 7-segment display so that you know what I'm talking about. Oh, this is perfect. So this is a 7-segment display, and as you can see, each segment is controlled by a cathode, and whenever light went up, so this is a diode, you have enough voltage to cross through the barrier here, it will connect it to ground, thus you have a complete circuit, meaning that it'll light up. So each number in a 7-segment display is controlled by an anode. So this is a single 7-segment display. Just think of these as 4. And in order for you even to see any lights, the anodes need to be on. So a common anode display means that all of the anodes are controlled by one voltage source, and a common cathode means all of the cathodes, so each of the segments are controlled by one voltage line. So for our purposes, all of the cathodes were common, and each anode had its own port, or its own input signal. So I could turn on number 1 and turn off number 3 at the same time, which you wouldn't be able to do that with a common anode display. So that's what I did. The IR remote and sensor, so the user has the ability to control the programmability of the alarm time using the remote. So this PowerPoint's actually backwards, but so when the timer turns on, it is flashing, or it's not flashing, it's just 0000, and every second, or you can change the time every second or every minute or whatever you want, it'll increase it by 1. So it'll be 0000, 0001, 0002, etc. So if you press the power button, you have the ability to change what the set time is. So like you can turn it on, you're not turning your alarm clock on midnight. So you can press the power button and you can use the numbers on the remote in order to change the program time. So if it's actually 2:06 p.m., I press the power button, I click 0206, press the power button again, and it'll start incrementing, but this time starting from 0206. And then for the setting the alarm time, there's this little button that's across from the power button. It's function stop. You'll see it in the video in a second. Function stop. So that is how you control what the alarm time is. And so the LED will be flashing, or the anode will be flashing, the number that we're on will be flashing, and you press the up or down button in order to change the time. I could have done it very easily with just the numbers again, or I could have changed the numbers and done the +1, -1 like you'll see in a minute for both of them, but I wanted to try out both ways for fun, just to see if I could do it, and just to, spice things up a little bit. So once you reach your desired alarm time, you click the function stop button again. And then the last subsystem I have is the output, which is the active speaker. That one's really easy. You just, whenever the display time is equal to the alarm time, you just turn it on and off a couple of times. So yeah, nothing too revolutionary here. So this is a parts list. It's very incomplete, but as you can see, this is a really easy project to put together. 7-segment display, remote control, the receiver module, the active buzzer, and the board itself. You can do everything here on an Arduino as well. Just my code won't work for you, but like if you had just think about if you have no idea what this means, just replace it with an Arduino and you can do it. So this is just showing you. So the IR sensor and the speaker and the segment display are all hardwired to the Nucleo board, and then the IR remote is wireless connecting to the IR sensor. So this is just a little picture of what's going on here. On the left, you can see I have my board and I have a bunch of jumper wires connected to a breadboard here. And here's the speaker. If you can see my mouse, here's the speaker. Here's the 7-segment display. As you can see, there's 4 numbers, and then there's the IR receiver module. And on the right hand side, this is my microprocessor pinout. So this is where all the peripherals are. And it's great, the software allows you to choose. So like on Arduino, you have specific inputs and you have specific output pins. And I think it's really cool for this processor, you can actually choose what the pins are. So these 1, 2, 3, 4, 5, 6, 7. As you can see, these are all GPIO outputs, and they're all, for the 7-segment display. So each segment is controlled by a GPIO output. And then you have the D1, D2, D3, D4. Those are the anodes for each. So D1, D2, D3, D4. And then you have the speaker over here. So those are all the output signals for the speaker. This GPIO external interrupt 11, that's the pin that I make my external interrupt happen for my IR sensor. So whenever it receives a signal, it flags a hardware interrupt, which has pretty high priority. So it'll do it, which is how I use my remote control. So I'll press the power button and then a hardware interrupt happens. And if you know anything about processors, is that you have an interrupt service routine, and depending on the priority, it will stop what's happening and it'll address the interrupt, and then it'll go back to what's happening. So I want that because I want my remote to have the highest priority. So this is a little bit of the block diagram of how my code works. So this is happening after you put in what the time is. So using timers, so in this case a software timer, the time increments once every minute, or for the intents and purposes of the video that you'll see in a second, it'll increase every second. And if it's not the specified time, i.e. the alarm time, we're just gonna sit idle, and it's gonna keep incrementing. But if it is a specified time, we're gonna play for 60 seconds, but in the video it's about 5 seconds. But if you press the function stop button, we're gonna be setting the alarm programmability, so we're gonna be setting what the alarm time is. Again, we do not use the number keys, but use the up and down. Use the number keys to set the real time. I left it like this in my block diagram because I could easily switch it. Which method I'm using, it doesn't really matter. And then if you press the function and stop button again, you exit programmable mode and the specified time is updated. So you go back here and you are sitting in this loop again. So we're gonna watch this video that I took. Just showing you how it works. So yeah, turned on. And as you can see, we're incrementing once every second. So yeah, this is, it's like midnight and so here I press the power button, and then I can press whatever time I want it to be. So I going to set the time to 12:55, and then I'm going to press the power button again. And look, we are incrementing. Isn't that cool? And then as we get to 12:60, it becomes 1 o'clock. So all the logic is there in order to have real timekeeping. So now I'm setting it to 23:55 in order to show you that after 11:55, it's going to roll back over to midnight at 00:00. And we're going to keep incrementing. So again, here I implemented some logic so that you can't put an invalid time in. So if I press like a 3 for the first digit, it'll just give you a 2. And if I press a 5 for the second digit, if the first digit's 2, it's just going to give you the 3. And then a 7 for the third digit, and then whatever I want for the last digit. So there's, of course, is how time is kept. There's constraints, and that's how it's kept. So next, I think I'm going to show you how the alarm functionality works. So I press the function stop button. As you can see, the LED is flashing. Now the value that's in there currently is just a variable in the code that I keep so that the initial turn on doesn't automatically flag the alarm. So I'm going to set here 12:42. And as you can see, the clock is still counting even though I'm setting the alarm time, which is how you want it. So here again, I'm showing you're keeping the same values. And then I'm going to change the time to be closer to 12:42. And I'm going to turn on the sound so you guys can hear this. And there you go. That's essentially a little rundown of what I did for my project. I will next I'm gonna cut here, and then I'm going to show my code, so stay tuned. Okay, so we're back. I've got my code pulled up, and before I get started, I just want everyone to know that I am by no means a professional software engineer. I do not do this as a job. I am learning. This is a part of my class, so I know there's a lot of things that people frown upon, and I'm not very talented, nor have I really studied it for a while. So this is just my rudimentary code. It works. So at the end of the day, I hope that's all that matters. But I'm just gonna walk through it, and I just want to show you what it's all about. So we have my include statements here, and then here I have a bunch of my variables. As you can see, that 55 that pops up whenever you turn on the programmable, it's right here. So a lot of cool things that I saw is that I can create like shortcuts here. So whenever I say D1 high later, so anode high, anode low, I don't have to type out this whole function, which I thought was pretty cool. So going down here to the segment numbers, since essentially all that we're doing is sending a binary, or in this case hexadecimal, a binary value to each segment, I can just store whatever number I want to send. So this is 0 through 9. So I'll just say I want to write a 0. So I'll pass a 0 into this, and then I'll give this function or this value, and then it'll come over here to the 7 segment update. So I write the pin whatever bit that I want. So this shifts it a certain number depending on, so this is the first, second, third, fourth, blah, 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 all the way down to 7. And as you can see, so I want the first one, and I only want one binary value because I'm only going to one thing. So if I'm sending a 0, it'll get the first bit of 0. So if A is high, then we'll get it here, blah, 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 all the way down. So this is how I turn on and off each segment. So this OS timer, as I was saying earlier, the timer function is controlled via software instead of hardware because of the middleware that I'm using, FreeRTOS. So just this is how we're defining that. And then we're getting down in here. Here's my timer handle. You'll see that later. And then the task that happens because of this thread. And then here I'm starting my software timer and my hardware timer. So this software timer is what's incrementing my timer, and then this hardware timer is what I'm using for my hardware interrupt that is based off of my IR remote. So now I'm going into my code. Again, I apologize, but this is how it works. So we'll get back to this later. So the way that I choose, so say we have a number, 1,000. How do we turn 1,000 into 4 different values to set up the digits? So it's actually pretty cool. So let's say I have the number 1000. For the first digit, I want it to be just display value divided by 1000. So there's no decimal or remainder or anything because these are integers. So the tempo 1 will be 1. And if we had a number like 2222, here you have that divided by 100. So that gives you 222. And then modulus 10, which leaves you with 2. So pretty cool. And then as you can see here, it goes down until you have one digit that is correct for each place of a 4 number 7 segment display. So I have that twice, and you'll see you'll see that in a minute. So if we come back up here, let's say we have a number, and since we're dealing with counter divided by 10 modulo 10, we're wondering about this third digit, or the tens place. So if we have a number that's 6, time doesn't go past 59 minutes. So if we're at to 6, we're going to go ahead, add 40, which essentially adds an hour. And if we are above, if the time is above 2400, what I want it to do is just take itself and subtract what we have in the first digit plus the second digit, so that if I'm setting the alarm or I'm setting the time and the alarm, I have, let's say, 50 minutes, and I go above 24 in the hour spot, it's going to keep the 50 minutes but roll over the hour spot back to 0. So I do that twice. This is for my alarm setting, and then this is for my display value, my base time. So segment flash is the flag that I use that I want to set the alarm. So what I'm doing here, if the alarm state is 0, which means I'm on temp 4, which is the rightmost digit, I'm going to be flashing on and off that segment, and I'm going to be sending whatever number I want. So this is where you see, if we're setting the alarm the first digit, it was the only one flashing on and off with the value, and I do that for all 4. So, but if segment flash is off, I'm not going to be displaying this temp value, which is the counter, which is my alarm time. I'm going to be sending tempo 1, tempo 2, tempo 3, and tempo 4, which is display value instead of the alarm counter. So here we have the speaker code. If the display value is equal to the counter 5 times, we're just going to turn on and off that speaker. So here we have my external interrupt, my hardware interrupt. So if this pin that's connected to GPIO pin 11, which is my external interrupt pin, if it's high, we're going to go ahead, and essentially what this is doing is there's a certain communication protocol with the IR remote, and we are collecting data from the remote. I did not write this code. Just going to let you know, I did not write this code. I got it off the internet. And so essentially what we're doing is we're creating this code here, which is a unique string of numbers for each button press. So essentially all this boils down to is that this is the function stop code that changes the alarm. So I'm going to be changing the flag state from between 0 and 1 depending on when I press it, and the segment flash ability. And this is the power button. So with that I can change time. This long line of code is 0 going down through 9. So just a brief explanation of what I do for the numbers. So whenever I want to change the time, I just reset the value to 0. And if I press 0, I'm not going to change the time. So I'm moving it on to the next case, which changes the next digit, if that makes sense. So this is 1. So now we actually have to write something. So plus 1,000, plus 100, plus 10, plus 1. If that makes sense. 2, 2,220, and 2. So as we see with the 3, you can't write a 3 in the first digit spot, so you're going to write a 2,000 instead. So as we get to 4, the same thing, 2,440 and 4. So again, for the second digit, we have to have some code in. If the first digit is 2, you can't write more than a 3 in the second spot. So if it's greater than or equal to 2,000, we're going to go ahead and only put a 3, etc. That essentially stays the same. And as you can see here, once we're adding 600, you can't have a 6 in the third spot. So it's going to be a 5, and that goes on for the rest of the code. So these are all the numbers up until 9. These are the up and down. So the up and down button. So if I'm changing my alarm and I press up, I'm going to change the counter by 1, and And then if I'm going to move over from right to left this time instead of left to right. This is the left button, so I'm changing which digit I'm changing whenever I press the left button, and the same with the right button. And then this is flag state equals 1, counter equals counter plus 9. So this is the down button. So the increasing of the value is easier than the decreasing of the value. So if you get to 0, yeah, for the first slot, you need to wrap it back down to 9. And then else you're just subtracting by 1. And then the second one, you get to 0, wrap it up to 50. And then here we had to do some a little bit of logic here. So if the third digit is equal to 0 and the first digit is equal to 0, when you press minus on the third digit, it'll increase by 9. However, if it's equal to 1, you can also do it to 9. But the difference is if it's the first digit's equal to 2, you can't go higher than the 3 in the second spot, so you wrap up to 3. And then a similar code here is if the first digit, the first counter, or the second digit is 0 and the first one is 0, when you go down, you will go to 2000. However, if the third digit is greater than 3, you can't have a 2 in the first spot, so you change it to a 1. So that's like if the time is 8 o'clock and you subtract 1 in the first digit spot, so the 1000 spot, you can't put a 2 there. You can't wrap it up to 2 or 28 o'clock. That doesn't exist. So it'll go down to 1800 hours. So 6 o'clock. Else minus 1000. So that's pretty much it for my code. I had a lot of fun actually with this project. I was able to learn a lot, and I had a really good time with the class. I highly recommend if you're in this degree program. So that's really all I got. So thank you guys for watching, and maybe I'll make another video next year. See you guys.